Hello all, welcome to the next session on storage area networks. In this video session, we will be discussing about storage infrastructure management activities, and also we shall discuss about storage infrastructure management in a virtualized environment. Okay, let us begin by understanding what are the storage infrastructure management activities. So there are five major activities in storage infrastructure management. We have availability management, the capacity management, performance management, security management, and reporting. Let us look at each of these management activities in a bit more detail. So availability management. So let us see why is it required. A critical task in availability management is establishing a proper guideline based defined service levels to ensure availability. So availability management involves all availability related issues for components or services to ensure that their service levels are met. Availability management involves all availability related issues for components or services to ensure that the service levels are met. A key activity in availability management is to provision redundancy at all levels, including components, data, or even sites. So the key activity in availability management is to provision redundancy at all levels, including the components, the data, or even the sites. For example, when a server is deployed to support critical business function, it may require high availability. This is generally accomplished by deploying two or more host bus adapters, multipathing software, and server clustering. The server must be connected to the storage array using at least two independent fabrics and switches that have built-in redundancy. So in addition, the storage arrays should have built-in redundancy for various components and should support local and remote replication. So that is your availability management, which involves all availability related issues for components or services to ensure that the service levels are met. Now let us move on to the next storage infrastructure management activity, that is the capacity management. Now the goal of the capacity management is to ensure adequate availability of resources based on their service level agreements. So the goal of the capacity management is to ensure adequate availability of resources based on their service level requirements. Capacity management also involves optimization of capacity based on the cost and the future needs. Capacity management provides the capacity analysis that compares allocated storage to the forecasted storage on the regular basis. So capacity management provides capacity analysis that compares allocated storage to forecasted storage on a regular basis. It also provides trend analysis based on the rate of consumption, which must be rationalized against the storage acquisition and deployment timetables. Storage provisioning is an example of capacity management. It involves activities such as creating RAID sets and LUNs and allocating them to the host. Enforcing capacity quotas for users is another example of capacity management. Provisioning a fixed amount of user quotas restricts users from exceeding their allocated capacity. Technologies such as data deduplication and compression have reduced the amount of data to be backed up and thereby reduced the amount of storage capacity to be managed. So that is the capacity management. The goal of the capacity management is to ensure adequate availability of resources based on their service level agreements or service level requirements. Now let us move on to the next activity, that is performance management. Performance management ensures the optimal operational efficiency of all the components. So it ensures optimal operational efficiency of all components. Performance analysis is an important activity that helps to identify the performance of storage infrastructure components. So performance analysis is an important activity that helps to identify the performance of storage infrastructure components. This analysis provides information on whether a component meets the expected performance levels. So several performance management activities need to be performed when deploying a new application or server in existing storage infrastructure. Every component must be validated for adequate performance capabilities as defined by the service levels. For example, to optimize the expected performance levels, activities on the server such as the volume configuration, the database design, or the application layout, the configuration of multiple host bus adapters, and intelligent multipathing software must be fine-tuned as a part of performance management. The performance management tasks on a storage area network include designing and implementing sufficient interswitch links in a multi-switch fabric with adequate bandwidth to support the required performance levels. The storage array configuration tasks include selecting the appropriate RAID type, LUN layout, the front-end ports, the back-end ports, and cache configuration when considering the end-to-end performance. So that is the performance management activity which ensures the optimal operational efficiency of all the components. Now let us move on to the next activity in the storage infrastructure management, that is security management. The key objective of the security management is to ensure confidentiality, integrity, and availability of information in both virtualized and non-virtualized environment. Security management prevents unauthorized access and configuration of storage infrastructure components. For example, while deploying an application on or a server, the security management tasks including managing the user accounts and access policies that authorize users to perform role-based activities. The security management tasks in a storage area network environment include configuration of zoning to restrict unauthorized host bus adapter from accessing the storage array ports. Similarly, the security management task on a storage array includes LUN masking that restricts a host access to intended logical units only. So the key objective of the security management activity is to ensure the confidentiality, integrity, and availability of information in both virtualized and non-virtualized environment. That is about the security management activity. Let us now move on to the last activity in the storage infrastructure management, that is reporting. Reporting on a storage infrastructure involves keeping track and gathering information from various components and processes. This information is compiled to generate reports for trend analysis, capacity planning, chargeback, and performance. Capacity planning reports contain current and historic information about the utilization of storage, file systems, database, table space, ports, and so on. Configuration and asset management reports include details about device allocation, local or remote replicas, and fabric configuration. This report also lists all the equipment with the details such as the purchase date, lease status, and the maintenance records. The chargeback reports contain information about the allocation or utilization of storage infrastructure components by various departments or user groups. Performance reports provide details about the performance of various storage infrastructure components. So, reporting on a storage infrastructure involves keeping track and gathering information from various components and processes. So, that is about the reporting activities. So, these are the 5 storage infrastructure management activities which involves availability management, the capacity management, the performance management, security management, and the reporting. Now let us move on to understand the storage infrastructure management in a virtualized environment. Storage virtualization has enabled dynamic migration of data and extension of storage volumes. Now due to dynamic extension, storage volumes can be expanded non-disruptively to meet both capacity and the performance requirements. Because virtualization breaks the bond between the storage volumes presented to the host and its physical storage, data can be migrated both within and across the data centers without any downtime. This has made the administrator's task easier while reconfiguring the physical environment. Virtual storage provisioning is another tool that has changed the infrastructure management cost and the complexity of the scenario. So, in conventional provisioning, storage capacity is provisioned upfront in anticipation of the future growth. Now, because the growth is uneven, some users or applications find themselves running out of capacity, whereas others have the excess capacity that remains underutilized. Use of virtual provisioning can address this challenge and make capacity management less challenging. So, in virtual provisioning, the storage is allocated from the shared pool of hosts on demand. This improves the storage capacity utilization and thereby reduces the capacity management complexities. Virtualizations has also contributed to the network management efficiencies. So, virtualization has contributed to network management efficiency. Virtual SANs and virtual LANs has made the administrators' jobs easier by isolating the different networks logically using management tools rather than physically separating them. So, disparate virtual networks can be created on a single physical network, and reconfiguring of the nodes can be done quickly without any physical changes. It has also addressed some of the security issues that might exist in conventional environment. On the host side, compute virtualization has made host deployment, reconfiguration and migration easier than physical environment. Compute, application and memory virtualization have not only improved the provisioning but also contributed to high availability of resources. So, storage virtualization has enabled dynamic migration of data and extension of storage volume, which in turn has contributed to high availability of the resources. So, in this video session, we discussed the key storage management activities, which include the availability management, the capacity management, performance management, security management, and the reporting, followed by the storage infrastructure management in a virtualized environment. With this, let us conclude this particular video session. Thank you.